We are now looking at section 5.2, which is about trigonometric functions of real numbers. Now from section 5.1 we learned that for any real number t, there is a terminal point on the unit circle. So remember, the unit circle is a circle of radius 1, which is centered at the origin in the plane, and its equation is x square plus y square is equal to 1. So now we will define trigonometric functions, and there are 6 trigonometric functions of any real number t, and we will use the coordinates x, y of the terminal points to define these functions. So that's why we learned how to find the terminal points. So look here in the table, name of the function, and then the abbreviation first, and then we will be definition goes after the table. So for the sine function, we only write sin. No, it's not sin, it's sine. We say sine, but it's sin. Then cosine function, we write cos, but we say cosine. Tangent, again abbreviation is tan, but we read it as tangent. Cosecant is csc, and then we have secant, which is sec abbreviated, and cotangent is cot or cot. But we while writing we use these abbreviations, but we read the whole name. So we define them like this, that the functions are defined as sine of t. So sine of, remember, sine is a function, like log is a function, square root is a function. You need an argument, right? If I just say square root y is equal to square root, this is nothing. This doesn't mean anything. Or if I say y is equal to log, then that is nothing. Okay, we have to have an argument here. We have to have an x here, an x here. In the same way, if I write y is equal to sin, then that means nothing. Okay, so we have to have either an x or a t or something over here. But we are not using x and y inside the sign. Why? Because those are the we are using them for the x and the y coordinates of the terminal points. So the sine function, we define sine of t is equal to y. So what does that mean? That if you have a terminal point, which means a point on this unit circle whose coordinates you know, then the distance that you covered from the starting point until this t where you are, then look at the terminal point associated with that t, and the y coordinate is your sine of t, and the x coordinate is your cosine of t. So for example, if you recall, the terminal point for Tp for pi over 4 is square root of 2 over 2 comma square root of 2 over 2. So remember, this is the x coordinate, this is the y coordinate. So if I ask you what is sine of pi over 4, so you'll say this square root of 2 over 2 because it's the y coordinate here. What is cosine? By chance these are same, so cosine of pi over 4 is also square root of 2 over 2. Okay. But now tangent of t is equal to y over x if x is not equal to 0. Okay, y over x. So what is y? Y is, so the tangent of t will be equal to square root of 2 over 2 divided by square root of 2 over 2, which gives us 1. So that's what we mean by. Then, so these are main 3: cosine, sine, and tangent. Okay. Now the other ones are kind of reciprocals of these 3 that we have mentioned earlier: sine, cosine, and tangent. So cosecant is equal to 1 over y. So it is the reciprocal of the sine. So you can see from here, we can also say that cosecant of t is equal to 1 over sine of t. Okay, we can also see that, and this is something we call an identity. We will look at it later in I think next section. Okay, so we have now defined all the 6 trigonometric functions. Cosecant t is 1 over y, secant t is 1 over x, and cotangent of t is x over y when y is not equal to 0. So what if y is equal to 0? Then what will happen? For example, if we see here, if we go to the point 0, 1. So what about tangent? So this is associated with, remember, pi over 2. So what is tangent of pi over 2? So it is y over x, so it will be 1 over 0. So this is undefined. Okay. So now, knowing these functions and knowing the terminal points of each of these t values, you have to fill in this table. I am not going to fill in. This is your job to fill in, and you should then memorize, know these values. So now note what I had shown you above. Remember that the cosecant t is actually the reciprocal of sine of t. So the cosecant t is the same thing as 1 over sine of t, and in the same way, from this one, sine of t will be equal to 1 over cosecant of t. So both are reciprocal of each other. Then that's what I have written over here. Then secant of t is 1 over cosine t, and so cosine t is 1 over secant t. So these are reciprocals of each other. Tangent of t is equal to sine t over cosine t. So tangent has 2 definitions. One is that tangent is sine t over cosine t, and also tangent is 1 over cotangent t. And similarly, the cotangent has 2 definitions. One is that it is 1 over tangent t, it is the reciprocal of tangent, but also cotangent is cosine t over sine t. Okay, why? Because remember, cotangent is defined as cotangent t, earlier we defined it as x over y, and x is cosine and y is sine. So all these now definitions are mixed. Okay, so now to compute values of the trigonometric functions for any real number t, we first determine their signs. The signs of the trigonometric functions depend on the quadrant in which the terminal point of t lies. The following mnemonic device will help you remember which trigonometric functions are positive in each quadrant. So it says all of them sine, tangent or cosine. You can remember this as all students take calculus. So it means the first in the first quadrant all of them are positive. In the second quadrant only the sine is positive. But if sine is positive, then cosecant is also positive. Okay, we actually mostly we will be working with sine, cosine and tangent. Okay, so that's why this mnemonic is only based on sine, cosine and tangent. Okay, so in the second quadrant, sine is positive, cosine and tangent will be negative, and anything related to cosine and tangent, like for example secant is related to cosine, secant is 1 over cosine, so that if cosine is negative, secant will be negative, and cotangent is related to tangent, so if tangent is negative, cotangent will be negative. Now cosecant is related to sine, and sine is positive, so cosecant will be positive. And the same way, so all of them, sine, tangent, cosine. So this is first quadrant, this is happening in the second. In the third one, tangent is positive, so which means cotangent is positive, but all other four are negative. And similarly now in the fourth quadrant, cosine is positive, and so sine and tangent will be negative. So what else will be positive? The one which is related to cosine, which is secant. So secant and cosine will be positive, but all other four will be negative. Here is another way of looking at it. Signs of the trigonometric function, quadrant 1, 2, 3, 4. In 1, all of them are positive. In second, sine and cosecant are positive. Everything else is negative, which is written here, and then so on. So you can look at the rest of the signs. Okay, now come the identities. I mentioned earlier, I thought it will go to the next section, but it's right here. So there are different kinds of identities here in the trigonometric function. First, these we call reciprocal identities. I have already mentioned it to you. So cosecant is equal to 1 over sine t, secant t is equal to 1 over cosine t, cotangent is equal to 1 over tangent t, and then tangent can also be written as sine t over cosine t, and cotangent can also be written as cosine t over sine t, because it's the reciprocal of tangent. So you flip this and you get that. Flip and you get that. Okay. Then we have a very, very important identity which is used in many places, many places. Okay, and it's called the Pythagorean identity. Okay. Now the first one is kind of the most important, and so once you are done with this course and you go to Calc 1, if you don't remember this, it means you did not learn your trigonometry. Okay, you did not learn your trigonometry if you forget this. This is very, very important. I don't know how many stars to put here. Very, or should I say extremely important. Okay, so what is this saying? Sine square t plus cosine square t is equal to 1. Okay, and why is that? Because if you recall, so this is happening, this is on the unit circle. Okay, so if you remember, on the equation of the unit circle, x square plus y square is equal to 1. But how did we define what trigonometric function equals x? We just defined the trigonometric function a little while ago in this section. So remember, x is cosine of t. So this, in place of x, I can write cosine of t whole square, and in place of y, I can write sine of t whole square equal to 1. Now this is kind of a note, this is kind of a convention, this is like a I think how to say it, like a accepted way of writing it. So whenever you have a cosine a trig function being raised to some positive power, you can write it like, so cosine of t whole square, we write it cosine square t. Okay, we do not write it like this. This will be wrong, okay, because this means the square is on t. So if you want to mean the square is on the whole cosine function, you either put parentheses and then put the power, or you write it like this. Okay? So which means now if you have cosine of t raised to the power 5, you will write it as cosine 5t, cosine raised to 5t. Okay? So that's how, when I write it like this one as cosine square t plus this one as sine square t, then I get the identity which is over here. We call this Pythagorean identity. Now from this identity we can actually get these, or so these are secondary. This is the most important one. If you remember this, you can get those. We will talk about that later, how we can get those. But for now, sine square t plus cosine square t is equal to 1. This is kind of basic Pythagorean identity. Okay, so here the first identity is the equation of the unit circle. I just explained that. Okay, now we come to our problem, which is asking us to find the exact value of the trigonometric function at the given real number. Okay, so remember that sine of t is the y value of the terminal point, cosine of t is the x value of the terminal point, tangent of t is the y over x if x is not equal to 0, and then we go on. Okay, let's see. Sine of 5 pi over 6. So what is the TP for pi over 6? TP for pi over 6. So where will be pi over 6? 5 pi over 6, I mean. So if you recall, so we have pi over 6, pi over 3, 2 pi over 6, 3 pi over 6, 4 pi over 6, and then we have 5 pi over 6. So here we are. What is the reference angle? Pi over 6. What are the coordinates of the terminal point for pi over 6? So that is square root of 3 over 2 comma 1/2, and since we are looking for 5 pi over 6, it will be second quadrant, so negative square root of 3 over 2 comma 1/2. So what will be the sine? Sine is the y value, so it will be 1/2. Okay. Next is cosine of 7 pi over 3. Okay, where is 7 pi over 3? So again, now it's you can figure it out. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3. Okay, so this is 7 pi over 3. What are the coordinates here? 1/2 comma square root of 3 over 2. So the reference angle will be this one, which is pi over 3. So we have the same coordinates TP for that, and so that cosine of 7 pi over 3 will be the x value, so which will be equal to 1/2. Okay, so notice here that you are not just supposed to give the value, just show somehow, draw this unit circle and the angle, so, or somehow write down, if you don't want to draw the picture, at least write something like this. What is your what is the terminal point for the t value? So this is the t, remember this is the t value. Okay, 2 pi over 6. Okay, first I am going to simplify. The 2 pi over 6 is actually pi over 3, right? So this is basically tangent of pi over 3. Okay, so it means we have to know the reference point for pi over 3. What is that? Oh, sorry, the TP, the terminal point for pi over 3. It is 1/2 comma square root of 3 over 2, and the tangent of pi over 3 will be y over x. So square root of 3 over 2 divided by 1/2, simplify, and we end up getting square root of 3. Okay, now we have cosecant of negative 11 pi over 6. Okay, the first thing I will try to do is rewrite it as 1 over sine of negative 11 pi over 6. Okay, but what is negative 11 pi over 6? Where will it be? So we are starting here and we are going in the negative direction, or the clockwise direction. So from here till here I have 6 pi over 6, right? Then I go, if you recall, there will be 3 pi over 6 is here, 3 here, so 6 pi over 6, 7, 8, 9, 9 with this one, 10 and 1, 11. So we land here. So our angle, reference angle, is pi over 6, and we are in the first quadrant. So in the first quadrant the sign is positive, and the y value will be positive, and so we end up getting 1/2. Sorry, 1 over 1/2. 1 over 1/2, which is 2. Okay, next is cotangent of negative pi over 4. Okay, where is negative pi over 4? So negative pi over 4 is over here, just this much. So what are the coordinates here? Square root of 2 over 2, comma negative square root of 2 over 2. Cotangent is, now you can think of it in different ways. You can say cotangent is x over y, or you can say cotangent is cosine over sine. What is cosine? Cosine will be this thing, and the sine will be cosine will be this, and the sine will be the y value. So it's x over y. So x is, and the y is, so it will be negative 1. Okay, then secant of pi over 7 pi over 4. Okay, I will leave this for you guys to try, and I'll see you in the next video. So by the time I get back, please try doing this one, so when we come, you see, we'll compare the answers.